Alright, another response video to Franklin Hugh of the Chappelle Natural Philosophy Society, which, I don't know. Be nice if I could separate him from. But anyway, have conversations separate from. This is the third video, just in case. He seemed to not realize that I already made a part 2 video, but anyway, I'll put the other 2 videos as links, the previous 2 videos. So the conversation started with the argument that he was making that the electromagnetic notion of things that move the speed of light as electromagnetic perturbations, and that they end up having 2 different field perturbations, that this theory isn't very well founded, that there isn't any real evidence that all of that is necessary, that you could just analogize it like a pressure wave in sound, that there's a certain amount of compression or quanta of compression, and that it travels linearly from the noise-making device, and there's no reason to have any extra dimensional movement of this thing, whatever this thing is that's moving, this quanta of energy, this force through the medium. Anyway, so I agree with him that there's no very weak evidence for any idea that there's 2 fields that exist at all, that you would label them something like a magnetic field and an electric field, like they always exist, and that something has to irritate the field to be a reality. I would argue that the field is the force. When the force exists, there's a field. When you have soldiers moving, that's a field of soldiers. If there's no soldiers, there's nothing moving. And the soldiers are just independent little soldiers. You can have 1 soldier, you can have 10 soldiers, you can have 1 billion soldiers. You can do your what do they call that thing with the beach, their D-Day thing. You can have your D-Day, and just wave the beach with soldiers. But they're individual soldiers. It's little bits of energy. If you want to call it an ether, then it's little bits of compression that are moving in straight lines. Which gets into the subject of how do you do straight lines with an ether geometry, and these are points I have made in the previous videos, and I don't think Franklin was entirely responsive to those arguments, but regardless. So the context is that nobody else in the room stays on the subject, clearly, and they all seem to have a wish to talk about first causes and all kinds of swirly vortices and all kinds of stuff, complex things, as elemental functions. And to me, that's very unsatisfactory physics. The universe really can't get more complex as you go down. The piston isn't more complex than the engine. That kind of, the parts have to be simpler, not more complex. And so it's the whole process of having conversation with people, because there is no conversation about the individual subjects in isolation. They always spread it to some other, just sort of as Franklin did. He was making an argument that the evidence for these 2 fields is weak, and then compounded it by pointing out how there must be an ether and there must be all this whole other structure as a replacement, when where you maybe perhaps should stop is, let's demonstrate that the evidence that there's anything called a magnetic and electric field is weak, that all they have is Maxwell's equations, and you can sort of do a little bit of analysis of those equations and see that the 2 fields are just contrivances, really, that they're always describing at any one time just 1 field in most cases, and it's only when light shows up that they decide that there's 2 fields at the same time. In most cases, it's either an electric field they're analyzing or it's a magnetic field, but only in the case of light or photons do they decide there's both fields, and that's why they end up with the speed of light. But they end up with the speed of light in all the other cases too, because the way the mathematics is drawn up. And as I have argued, I think sensibly and reasonably, you could just turn Maxwell's equations. You could just say there's one field. Just get rid of the B for the magnetic and the E for the electric. Just call it F for field. And just recognize that when you're talking about a field created by a dipole, it's different than a field created by a monopole. And just recognize that, yes, you change a couple things. The R squared goes to an R cubed. Simple little things that you change when the circumstances change by what's emitting the force. So when a dipole is emitting it, it's different than when a monopole is emitting it. But it's not a fundamentally different force. It's the same force. And there's just a couple of subtle changes to how the force behaves. And they're just subtle changes. And I think that can be made as a rational argument that the bifurcation in Maxwell's equations is unnecessary. As long as you have rules. There's always rules governing the mathematics. There's always assumptions built into any formula. There's assumptions that make the formula work, and there's circumstances where they know it doesn't work. And so as long as you understand that, when you're applying the equation, you can have the same equation and apply it to both. And you just recognize that the only difference is, you change the R squared into an R cubed. So all these conversations are difficult because they always go off on tangents, because people have their own agendas and they have their own theories they want to argue, and they're not really up to date or complete on somebody else's theory. They've heard the 5-minute version of their everything theory and have little hope of being able to argue it because they haven't really heard it. Oh, jeez. Okay. You just move a little bit and something goes wrong. Yes, Franklin seems at least attentive, and he appreciates what's being argued, and even appreciates these when people are off the subject and all that kind of stuff. So it's a lot. I see some hope in having conversation because he seems reasonable, where many of these dissidents don't seem very reasonable, and talk in gibberish language about bizarre concepts. The unicorn ate the gremlin, and it made a fairy princess. I mean, stuff that just you can't conceptualize as anything but just made up gibberish. So so I would argue that this process requires us to set some sort of boundaries to the conversation and just establish some things like, well, maybe we could all agree on conservation of momentum, that's one of the rules, that you can't just have something happen for no reason, something move for no reason, and you can't destroy movement, that somehow you have to account for it, because the movement really can't be destroyed, the energy can't be destroyed. And if we could agree on these kind of simple rules about function, then maybe we can confine a conversation into some sort of reasonable platform from which you could take one step and take another step and take another step about what we can agree on. And as I've argued before, ultimately these conversations, in my opinion, only have one purpose. I mean, any dissident theory can't possibly replace the existing theory until people understand why there's reason to doubt the existing theory. So the first obligation is essentially to point out how it is all weakly evidenced, how there are possible explanations that they haven't considered, how they've jumped the evidence. I've used this terminology over and over, but I think it's just obvious that this is the truth. That's what physics has done, has jumped to conclusions way too soon on way too little evidence. Superficial similarities. It seems like, therefore it must be. It's that obvious. They do a lot of it seems like, therefore it must be. And instead of saying things like, well, we might have discovered a gravitational wave there, we're sure we've done it. That kind of thing, where that level of confidence is just not justified by the facts. And they do that with the experiments. Very poor experiments they claim are decisive wins, and nail in the coffin evidence. It's not even close. So they're insane, almost exaggerations of how deep their evidence pool is, and it's terribly shallow puddle. Now, if we can get people to understand that, that's a huge first step into being able to say, well, look, here's some alternative explanations for the phenomena you see, and they don't require dualities and all kinds of spontaneuses and entanglements and all kinds of spinny, wooey stuff. And so, as I pointed out, though, most of the other dissident theories are all agenda theories proposed by people who want to make the universe fancy and interesting, either because they want to put a god in it somewhere, or just because they like glitter and sparkly stuff, so they want to create a bunch of spinny, vorticey, fractally, blah blah blah, because that's much more interesting than dominoes. Newton's cradle, kinetic banging, binary digital processing, deterministic mechanism. They don't like being robots in a robotic universe. And so their theories are just as more weakly evidenced. They just make up stuff that you can't disprove because it's just made up. Fairy vertexes, the fairy godmother makes them. Just nothing. So if we could agree on laws like the conservation, and maybe start with the premise that, well, let's try to describe the world as if we had an ability to freeze it as it is, the universe. We could just freeze frame it. Then somebody who's going to propose how the universe works should be able to explain where everything is and where everything is going, in a simple kind of way, where if there's a vortex, some explanation of how the stuff is vortexing, or how this little tiny pixel is somehow going this way, and then it's going to go this way, and then it's going to go this way, and some explanation of why is it going to do any of that stuff. Some explanation of what other things are heading right for it that are going to push it in that direction or make it go that way. What's the explanation? So you should be able to pixelate the whole thing into little discrete locations in space in 3 dimensions and say this is where everything's moving, this is why it looks this way. And so, for example, like to explain velocity, I could freeze the bullet in space and show Franklin that there's a bunch more arrows going this way, little bits going this way, than there are bits going this way. And that's why the bullet's going that way, is because it has more energy in it going one way than it has going the other way. And that all atoms are trapping energy. So clearly every atom that's trapping energy can trap more of it in one direction than it traps in another direction. That's not too complicated. And I could almost make the example of 2 ping pong paddles. I might as well do this argument. This is his first argument in his video, which I'm going to have to replay because I had a failure earlier. So if I had a little bucket that was frictionless and it could move side to side, and I threw things into it, you could sort of get the idea, and the things could bounce back and forth. So the energy was trapped, but it was also created momentum. So let's just understand that's the rule. So when it goes in, it moves this, gives this momentum, and then it just traps, and so it just goes back and forth, back and forth. Or you could say it stops, it doesn't really matter. So you throw it in, it creates momentum. And you throw one in the other direction, it stops the momentum, right? Deaccelerates it, then it accelerates it and deaccelerates it. You can sort of understand that where this thing's going to go is going to be dependent on how many I throw this way, how many I throw this way. And if I throw more this way, the bucket's moving that way. And it's going to keep moving that way if it's frictionless, because it has captured the bit. And then if I stop the bucket, the ball would fly back out. The last one in anyway. It'd have the energy to throw it back out. So in that sense, you can understand how a bullet has energy in it, because it's captured a bunch of stuff going one way. It's absorbed it. It's now inside the bullet as a direction. The energy's been trapped. stored, captured. And I would argue it's obviously, in my opinion, kind of obvious, it's trapped between the electrons. That's why they're repulsive, is because they've got stuff bouncing back and forth between them. That's why they repel each other, is because they're really good at capturing energy. And that they have a bias in a direction. Most of the energy they've captured is in one direction, and that's the direction they move in. And then when they hit something, what are they doing? Well, they're stopped moving, so they're doing the kinetic ball thing. I stop, and all the stuff, all the cars inside of me that are still moving, all the little bits moving in the biased direction, more going this way, all of those little force bits, that radiation, goes into the thing. And it goes in as vibrations of electrons, creating pressure on electrons. And if I create enough pressure on the electrons, I start breaking the atoms to pieces and moving them around, and I make a hole. So anyway. Alright, so let's play the video and continue. But yeah, there's a real difficulty in having conversation with people because there's no equality in understanding each other's vision and in terms of being informed about what the total theory people are arguing from, what the foundation is they're arguing from. And if you don't have that, you know, there's always this objection. Well, you haven't explained. When, yeah, I have. You haven't explained. Yes, I have. You know, and they just haven't heard that explanation. And so there's always this breakdown in trying to have a conversation about a single subject and deal with all the implications of that subject. And it just ends up, everything just drifts off the subject, really. Not saying it's Franklin's fault, not saying it's anybody else's fault. It's just a fact that I would argue that most people argue from positions where they haven't taken the time to understand another person's position, and yet they're debunking it as if they know their position. Franklin even sort of makes this point that you can't really argue somebody's theory until you understand their theory. You know, kind of a bogus if you're trying to do that. Alright, so somewhere around here we'll start.
Which is you have to explain, you know, why is it a particle in motion stays in motion, and you have to explain why we get what is called inertial resistance.
Right. So this idea that, you know, that's just Newton's rhetoric, okay, that things want to stay, you know, and there's no will to do that, obviously, or that there's some fundamental resistance. It's just that they all have mass, and you have to move all of the mass. So if I put a bunch of kinetic balls in a row, 50 of them or something, you can sort of understand if I click one of them, you know, you could watch the compression. You know, if I put them all a centimeter apart from each other, you could watch the compression move, and you could say, okay, well, any one time, only 2 of them are moving, or 1 of them even. So all I've done is put 1 ball's worth of movement. I mean, the whole row of balls can't move that way, right? I mean, I haven't put enough energy in. I put 1 ball in, I get 1 ball out. So that's why the space shuttle, you see a big giant flame coming out of one end, right? Well, what do you think's going into the other side? The equal and opposite reaction. So a bunch of energy equal to that giant flame that's shooting out of the tail, an equal amount of energy that you're not seeing but is real, photonic energy, electron pressure, is going into the shuttle. So you're not hitting one little ball into all the balls and saying, why doesn't the whole row of balls move? Well, the whole row of balls isn't going to move until you click, 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 click. You keep clicking it until you get them all moving, and then they can all move. So obviously it takes some time to get the energy into the object, because there's a lot of energy, a lot of little atoms inside the substance, and you're putting the energy in one spot. So you just like electricity takes some time to get through a wire, it's going to take some time to for the pressure you're creating on the electrons to migrate through the entire substance and give them all a bias in a direction. So you have to tilt them all, essentially. You have to tilt every single atom to make the thing move.
So like if I take like an automobile and I place it on a an air table, which is perfectly frictionless, and I start pushing on that thing, then you know that it just can't push. Okay, we're getting a big echo here. Someone needs to mute themselves. Let's see. Okay, might have been someone on the phone there. I'm gonna.
Yeah, there wasn't quite as many technical failures like that, so that was like the only glaring one that I heard.
Mute that. Okay. So I was trying to explain what we have to, that we've got this inertial resistance that if you push a very large mass, it takes a lot of energy to get that thing moving.
Right, and like I said, by my theory, it's because there is difference between the force bits and the matter bits. So the matter bits do actually have to absorb force. You have to actually keep pushing them along. You know, they don't have like a photon perpetual energy. You have to keep hitting them. And so the force actually has to be captured and keep pushing it along.
Right? Now what that is this this pushback basically from the material ether. And as you try and accelerate an object through an ether, that pushback that you get comes actually from having to break all these ether bonds as it moves forward.
So again, this idea of the ether is fine, okay, but now he's created the ether that has the tension in it. So he's created a spring-loaded kind of ether. That is, everything's locked together. So this way you can, you know, compress it and it decompresses all by itself, you know, kind of idea. So the springing domino idea. So some way to restore it to its original condition after you perturbate it. And the liability of that, though, that tension like water waves that creates the bowing of the wave and creates the idea of the continuity, and it also creates a tremendous amount of drag, and that's why the energy that dissipates in water is huge, the amount of losses you have by comparison to a photon traveling billions of light years through space without any apparent "I'm getting tired" syndrome.
Forward. Now, for someone who doesn't believe in the ether, they have to explain that somehow as well. I mean, why is it when I try and push a car on a frictionless surface, it just doesn't go just completely straightforward, and because there's nothing resisting it?
It goes completely straightforward. I mean, every bit of energy you put into it is realized in motion quite immediately almost, but it takes time for you to get the energy in it. So again, you're just saying that somehow, because your two hands, you know, you can't convey another automobile crashing into it, right? If you want to go 30 miles an hour, you have to hit it with a 30-mile-an-hour car, and then it can, the one car can stop and the other car can leave 30 miles an hour. So there's going to be energy conservation, and there's nothing in a particle theory of energy transfer that in any way breaks those rules. I mean, there obviously has to be energy in the thing that's moving, and the thing has more bits going this way than bits going this way, and it's just a fact. That's what it's done. It's absorbed more bits of energy in one direction than going in the other direction, and you can see that in like the bullet in the gun. Again, there's a huge explosion, a huge recoil. You have lots of evidence of energy going that way. All right, and all you're saying is because I don't see the flame going this way, because I don't see the bullet on fire, I'm assuming the bullet hasn't absorbed energy, when no, it's done exactly that. The amount of energy equal to that flame going the opposite direction has been forced into the bullet. The bullet's full of energy, full of photons, full of stuff moving in a direction, full of stuff moving the speed of light in a direction. And what it's doing at the speed of light is essentially continually hitting in one direction and avoiding hitting in the other direction. So it's something that can keep pushing forward because it has impacts in the forward direction and no impacts in the negative direction. You know, simple kind of rule like that. Kind of like a clock spring. It only pushes one way on the gear. But the fact is that's all that's happening. You've transferred the energy, and you've done it kind of obviously, in the sense that you've created an expansion, and all the energy going this way you've let fly out as all kinds of heat and waste and stuff you can see, and all the energy going the other way is inside the projectile.
Right. it should just immediately accelerate as fast as your hand touches it, and there should be no resistance at all, right? If there's nothing, right?
So again, why wouldn't there be resistance? There's a ton of atoms that you have to reconfigure to have energy in one direction, so they have more torque in one direction than they have in another direction. So you essentially have to, like if you had a ball sitting in space and you were going to hit it, spin it. The idea is that the motion is going to be transferred either into spin or into forward motion. And so it's real energy. So if you either way you do it, you've conveyed energy in one direction. So you're not really going to be being able to avoid the fact that even if you put spin energy into it, even if it's already spinning and you just give it a tap in the same direction, that tap's going to mean it's going to move. You can't spin it in isolation in space. So you're just being fooled by air resistance and saying that's something fundamental. And it's not fundamental. So if you get rid of all that resistance, it will in fact push fairly easily. But you have to put enough energy in. Again, to move 1 million atoms, you can't put in 1 atom of motion. It's back to the kinetic balls. You can't move the whole row of kinetic balls by just hitting with 1 ball, because then only 1 of the balls is moving. You have 1% of the balls. So you can't say, why doesn't all of them move? Well, because you haven't given enough energy to move all of them.
So for a person who does not believe in material ether, your problem is that you have to explain why is it you get this inertial resistance. For someone who does believe...
So again, I would say there's no inertial resistance beyond the fact that you have to supply the energy. And so a kinetic, Newton's cradle sort of demonstrates it. There's no real resistance, okay? I mean, 1 ball goes in at a speed, the ball leaves at the same speed, get rid of friction, and it goes on forever and ever and ever. It just swings back and forth forever. The pendulum just keeps swinging. So there's no resistance in any real way to the transfer of the energy if you have a mechanism to transfer the energy quickly. And the kinetic ball obviously doesn't do it instantaneously. There's some speed to the transfer, but it's obviously a very tiny amount of time it takes to transfer the full portion of energy, because everything's in a very rigid state, and so it's very easy for the electrons to absorb the current, so to speak, the electricity or the pressure you're putting in. So you can think of voltage as pressure, or you can just think of pressure as pressure. And the fact is, that's what you're doing. You're compressing electrons. When the two things hit each other, the electrons are getting compressed. And the question is are the electrons on the 1 ball going to be compressed this way, or the electrons on the other ball going to be moved? And that's the kinetic reaction. It's going to be all or nothing. So the transfer ends up being complete. The ones hitting transfer all their energy to the ones they've hit. And it doesn't take much time to do that, because it's moving all the speed of light in these little force bits. So the little force bits go into the other atoms, and they're essentially doing the same thing they were doing when the ball was falling, which is they're pushing the atoms, they're pushing the electrons and the protons. It's all being pushed, and now you just transferred the push. So you didn't transfer any matter, you transferred the stuff between the little matter bits. You transferred the stuff moving the speed of light. You transferred force. And force is photons, force is gravity, force is magnetism, force is electricity. Those are all things that only happen because there's photons, so to speak, little quantas of energy being captured between electrons, primarily.
In the inertial, in material ether, then that solves that problem, because it provides material resistance that you need in order to justify this inertial resistance.
So again, you don't have any inertial resistance in the kinetic ball example. There's very little inertial resistance. So how come the huge inconsistency in your ether? How come in one case it's so hard to get the energy into the object, and in the other case it's so easy to get the energy in? So you're still back to an atomic explanation. Some substances crush, The substances are elastic or inelastic, and that makes a huge difference in how easy it is to get the force into the substance, how well the substance spreads. The water molecules versus sand molecules. Okay, if you're pushing on sand, it's going to be really hard to get the energy into all the grains of sand. Okay, it's really hard to do. But if they're all locked together, and you're a little ant and you're just pushing on a water droplet and it's got adhesion, well, then you can roll the thing, you can push it without breaking it, without it absorbing the energy in some kind of destructive way.
So you just can't arbitrarily take a mass and just arbitrarily accelerate it.
So nobody says anything about any arbitrary acceleration, so I'll take a point off for that innuendo that I would somehow suggest that you can just arbitrarily accelerate something. Clearly, I don't believe that. And I haven't suggested that ever in any video ever, that there's anything called an arbitrary or spontaneous movement.
You have to go through this relatively thick ether, and that stops you from accelerating.
So again, he's admitting it's thick, he's admitting it's stopping acceleration. Well, if it stops acceleration, then it's going to degrade velocity. So then you're still stuck with having to explain why there isn't a tremendous amount of drag quite obvious in the function of your universe. Why don't photons get tired?
So the other problem that the non-etherist would also have to explain, which is, how does inertia work? So when I fire a bullet,
that's the same subject. So again, the word inertia is just so, which we're back to Newton's description, or some more rational, in my opinion, description. There's no will of anything to stay where it is. There's just an obligation for you to move every single atom, every single subatomic part. Every electron, like if you think the electrons are spinning around the proton nucleus, you have to understand that the nucleus isn't going to move for free. The electrons aren't going to go in some new direction for free. If you're going to move that object, you have to move it with something. Something has to hit it, in my opinion. You can't just say it moves because it felt like it. So it has to move because the atoms are locked together. They're sharing an electron, something else, so they're tied together, and you move one atom faster, and the other one slows it down, and the whole thing turns a little bit and all that stuff. So yes, but the energy is going in. You're pushing the energy in, and in the end, it's all going to be transmitted to every single thing in the object. So I could argue that in hard substances, all I have to do is poke one electron. I poke one electron on the surface, and I would say theoretically that one poke travels everywhere eventually inside the object. It just goes forever, likely. And in the sense that we sort of understand that once energy gets in those kind of things, it doesn't radiate easily. Some substances radiate heat very easily, some substances don't. But the point would be is that you have every reason to believe that that one poke doesn't die. It stays inside, or it comes out as infrared, or some other it comes back as some poke back at the universe. So if it doesn't come out as a poke to the universe, it's still in the object, moving around, bump, 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 cascading inside the mechanism. And with each one of those cascades, it takes one little piece of the item and moves it in this direction. And one more piece moves in this direction, a piece moves in that direction. So it slowly but surely spreads its momentum through everything. So you could take one photon and put it in, and you could say the material thing has a weight of 1,000,000 photons. And so you would just say, well, if the velocity is the speed of light, and I'm going to divide it by 1,000,000, then I'm down to 3, okay, versus the speed of light. So I have a huge number to grade. So the item will move 3, okay, 1/3 millionth of the speed of light. So whatever 1/1,000,000th of the speed of light is, that's what it's going to move. So it's going to move 3 little putrid units, 3 little quanta worth of distance in that amount of time. Because you're basically just spreading the 1 to the million. You're just doing a kinetic equation. You're saying if I make the ball, one ball 1,000,000 times bigger than the ball I hit it with, you still understand that in a kinetic ball, if the ball hits and it stops, and its energy goes into the big thing. You know the big thing is just going to move 1/1,000,000th the speed of the one little thing. That's the rule. So obviously energy transfers can be a little bit complicated. When you're just hitting something with one small little push, your little hands pushing, you have to, it's going to take you time to push in enough energy to get the thing damn going. You just don't have enough time to push in the energy. And if somebody gave you the mass, made you big in terms of your pushing strength, it'd probably crush your arms. Okay, so if your obligation was to hit the car like you were a car moving 30 miles an hour, well then you have to, because your mass isn't big enough, you have to increase your velocity. So you'd have to hit the car going 600 miles an hour, or I don't know, 10,000 miles an hour. So your little arms would just crush because you'd be hitting it at such a high velocity to make your mass equal to the mass of the object you're trying to move. So those are just kinetic arguments. So I'm surprised you're tripping over that one, as if hard transfers of energy, hard particle transfers, can't completely explain why it takes time for a little tiny pebble to move a giant rock.
We know that there's chemical energy in the bullet before it's fired, and that when we fire the bullet, it is released. And
well, let's say the chemical energy isn't in the bullet, so let's understand the part of the bullet that's going to be leaving has nothing to do with the explosive that's propelling it. So the cartridge and the explosive stays behind, the bullet goes.
And when the bullet then flies across the room and hits a wall, we can quite clearly see that there is that chemical energy is then released against the wall.
It was being the chemical energy that you're saying it was chemical energy. Obviously, it's not chemical anymore when it's turned into photons. So as soon as you've unchemicaled it and turned it into a bunch of radiation, and that's what you do, you turn it into a bunch of infrared photons and a bunch of visible photons, and a huge amount of pressure that I'd almost say was gravity, but regardless, you've created a bunch of radiation, and the radiation was felt in the rebound of the there's a word for that, not the rebound, but whatever, the ricochet. It's just funny how words just disappear. I know the word. Well, fuck it, doesn't matter. So a huge amount of energy going one way, and obviously the bullets absorbed all the energy going the other way. It's full of those little photons. It's full of just as much heat and power and visual energy. All that visual energy you're seeing at one end, it went into the bullet. It's just invisible because it's inside the bullet. You can't see it when it's inside the bullet, but it's in there.
We can see the energy there, but a philosophical question has always been, where is the energy of a bullet stored while it's in flight?
Between the electrons. That's why electrons don't like each other. It's because there's energy trapped between them. And between the protons and the electrons in the nucleus, the whole thing is charged by the experience. Every one of the atoms is charged by the experience. That is, all of the relationships between things. If there was two things and they're just sitting in this position, let's say electron and electron, and they have a certain amount of energy inside of them. The new energy came in, and essentially is coming in a direction, and that direction is essentially fed into their pressure. And so they might release energy in this direction and absorb the energy in this direction. And now they have a bias. So now the system has more energy going this way than it has going this way. And so the bullet's going to move this way. But it's moving every atom to do that. Every atom has its own propulsion, so to speak. It's absorbed the energy, or it's shared it with each other. You know, the atoms are tied to each other, so they share the energy because they're tied to each other. And it's all caught as a function of the electrons. It's the electrons. Matter traps energy. That's why matter is in its form, is because it has trapped energy. It's trapped pressure, high pressure between things, and it's created a vessel that holds energy. And when the bullet has velocity, it will demonstrate in some respects the fact that it has that. I mean, even in space, if I shot a bullet, you might see the bullet get hot. The bullet might actually radiate infrared radiation. It might leak some of the force it has absorbed because it didn't hold it quite right. It didn't hold it well enough. So you might even see some leakage, even in space. Clearly in an atmosphere you do.
So, you can look up this question. That's kind of a famous question. Because if you look at the bullet, it's in the middle of flight. If you were to freeze it in time and look at it, and, you can examine it with a microscope all you want.
So again, this idea, you can examine it with a microscope all you want, as if a microscope can see electrons and see the energy between the electrons and see why electrons are repulsive. So, so the clear argument is, yeah, I wish I could do that. I wish we could, because then you'd see the difference. You'd actually see that more little balls went in this way. Okay, it released little balls going that way. So I threw some more this way into the bucket. Okay, and I released some that were thrown this way previously, and I let those out. So I got rid of the ones going the wrong way, and I added some going this way, and now my cart's really moving fast. So if I dump the balls that I captured that came in this way, and I just dump them, shoot them out the same speed they came in. I just shoot them out the back, going the same speed, and I collect the ones that went this way, the cart's going to move because I've exchanged energy in the wrong direction, that way, for energy in the right direction.
But you would never tell any difference between that bullet and...
All right, so again, this should be, there should be a little bell that goes off in your head and say, maybe this isn't a fair argument, because, yeah, maybe I can't see atoms with a microscope. Maybe I can't see gravity, and I can't see magnetism, and I can't see any of these fields, and I can't see any of this ether you're talking about. So, I mean, this idea that, can I claim this thing too then? I say, well, if I can't see it in a microscope, it doesn't exist. So therefore your ether doesn't exist because I can't see it in a microscope. I mean, very lame argument. Clearly, I would argue, if you could really see the guts of the bullet, you would dramatically see that if the red balls were the ones you threw this way into the cart, and the blue balls were the ones you threw this way, that the bullet has a lot more red ones than it has blue ones. And that's why it's going really fast that way.
The bullet, which is just stationary inside the gun, So where is the energy while it's traveling?
It's in the electrons, in between the electrons. It's the photons, the radiation. It's in the form of force bits moving the speed of light. So you could think of it as gravity because that moves the speed of light. You can think of it as magnetism because that moves the speed of light. Or you can think of it as photons because that moves the speed of light. But that's the form it's in. It's in quanta moving the speed of light. The bullet has more quanta moving the speed of light going one way than it has going the other way. Therefore, it goes that way.
So, as an etherist believing in this kind of this spring tensioning kind of ether, which is constantly storing and releasing the energy to anything which is in motion.
So again, I don't know why you would think of it as storage when you just have a perturbation moving, a compression that moves in a direction. How is that storing anything? To store it, it has to get trapped in some sort of mechanism, circular, square, back and forth. So I would argue the only place that can store energy has to be matter. You can't store it without matter bits, and the storage would be between them, the pressure between them. So there's no other way to store these little photons except to trap them in futile paths that just go back and forth. Right? That's storage. If a photon goes in and I trap it and it can't get out, it just keeps going back and forth. Obviously, where it was going isn't going to get hit by it anymore. So it's changed reality out there because something's not getting hit by it because I've caught it here. Okay, it's stuck here. It's not going to hit anything over there. And then I can have a more sophisticated trap where, yeah, it hits this, goes left, and makes 4 turns, and now it's trapped in a circle, a square. I can trap it in a triangle. I can have it go down and up and down and up and down and up. I can trap it. So matter bits trap force bits. I mean, that would be a huge advance in this conversation if we could just get to that idea that there's two concepts. There's this force stuff moving the speed of light, and then there's the slow stuff that has to be pushed by the stuff moving the speed of light. That would be a huge step forward, in my opinion, if we could agree on something like that.
I would say that energy is actually being stored in the ether itself. The ether being considered like a bunch of springs, and the faster some object is going through, the more tension is on those springs, and the more energy is being returned back to the object. And when the object reaches...
So again, that implies, though, that you'd have all this side springing going on, all this ripping of springs, all kinds of stuff, and every forward motion would end up with a bunch of lateral motion. And clearly there would be huge resistance to any forward progress.
The wall, all of that tension is then converted into what we see in the destruction of the bullet and the wall. So, but it would be basically when it's fired, energy is stored in the ether, being carried along by the bullet, and then when the bullet has to stop against the wall, all of that energy is then converted into what we see, which is heat and noise.
So I would argue that the bullet just represents a bunch of cul-de-sacs. I don't think they're really cul-de-sacs, but I'm just saying traps. You put some energy in, it got trapped inside of those cul-de-sacs. It's trapped inside the object, but its initial momentum is real. It went in one direction, so it already put a bias into the system. There's a real bias. The first move is the only move that really matters. The rest is all going to be circular, so it's going to equal 0, 0. So all of the circular movement through the cul-de-sac, so to speak, would equal nothing. The spin. All that would equal nothing, because every time you're canceled everything. And all you're really left with was the first movement in the end. And all you're doing is slowing down how fast the thing moves in a direction, because you're creating a circle. So you're causing it to go into a null time path, a path that has no, that's of just eating time. So it's like it's moving in a straight line, and all of a sudden you make it disappear for a while by going a circle. And it's like it just kind of is done doing anything. And then if you released it, it would go right back to its linear path, because that's the momentum. If you undo the zeroing of the circle, the momentum that's left over was the initial movement into the circle. So it still has a bias in that direction, and it will go back to being a straight line again at the speed of light. That's the trap. That's what matter does. It absorbs energy, traps it for release at a later date.
And other forms of energy. But that's because it was literally stored and transported from one location to the other.
Exactly what I would say. If I shoot a laser beam at something and the laser beam goes into it, right? We see that now because we have such powerful lasers. You can just move objects with the laser beam. Well, what's happening? The photons are going inside the thing, okay? You're putting the speed of light force, slowly but surely, you're injecting it with speed of light little bits that are going to get caught in cul-de-sacs, but they had an initial momentum in a direction, so that's going to be the direction the thing moves in.
Using a material ether. So, because this is gas physics reasons, like why do you have to have a medium? What purpose does it serve? So I would say the purpose of it serving is to justify inertia.
All right, so he's claiming that the need for the ether is to create the drag of acceleration, when I would simply argue that no, you don't need an ether to explain why it takes time to put energy into something, especially if you're doing it with only partial contact, and especially when you're doing it with things that are bendable or flex, that elastic problem, things that have a inelasticity is going to make it, that's rigid. It's just, I hate the way they have those words backwards, right? That just makes everything so confusing. Somehow elastic means hard and inelastic means soft, or bouncy. Anyway, but as I've explained, there's perfect examples of where that transfer happens very, very fast, where you can move a lot of energy, just like you can put a ton of energy through a little tiny wire. ton, I mean, just an insane amount of energy. I mean, a little 1/4-inch thick piece of wire. And I've seen them shorted, okay, the 16,000 volts, 8,000 and 8,000. I've seen them shorted, and it's an insane amount of energy going through that stupid little wire. Photons can do amazing things. And those are photons going through the wire. I mean, they're the same thing as photons. They're little quanta moving really fast, the speed of light, and it takes them time to get through the wire because they have to transfer between the electrons. Again, the point is that the photons move electrons. They hit them. That's the force, the repulsive force. And when one electron moves, the other electron's going to feel it because it's got little force bits bouncing back and forth between it. And as I move the paddles closer together, the pressure goes up because the hits happen more often. So you can't move an electron inside of an atom without pressurizing all the other electrons. So the pressure just has to move. It takes a little bit of time to do that. So it doesn't move at the speed of light because it takes there's a little bit of lag because the electrons actually have to move, and they don't move at the speed of light.
And inertial resistance, right? You've got to be able to explain those two things.
Yeah, well, there's no problem explaining it, and so this, again, it's a little irritating when somebody tells you have to explain something you've already explained like 6 years ago. So it's like they just, again, you're arguing with a theory you really haven't heard, and you're just assuming that somehow these are unanswered questions, when no, they really are answered. Really completely, in my opinion.
And those two things are more explainable in terms.
So again, he's just stating it's more explainable with an ether when he hasn't even heard the other guy's explanation. So he's just saying, my explanation is more explainable. I haven't even heard yours, and I didn't hear his, and I certainly didn't hear his. But I just claim mine's more explainable. That's a little bold. I mean, clearly I'm not conventional physics. So yes, you've heard conventional physics' argument. Okay, and I would agree that their argument sucks. Okay, theirs is silly. But don't presume that nobody else came up with a better idea than their crappy idea. And that nobody who thinks in terms of particles hasn't already thought about these questions and come up with perfectly good answers. And that's sort of what you're assuming here, because you haven't heard it, therefore it doesn't exist. Well, you actually have to look for it. And, again, if somebody wants to argue my theory and say it fails, and they're not willing to do the work of understanding the theory, I mean, it takes years to understand conventional physics, right? You have to take 4 years at least of physics to understand their physics. I'm not asking you to take 4 years. I'm just asking, well, at minimum, you're going to have to listen to a couple hours of videos. At minimum. Or there's no real point in pretending you know what my theory is.
Of the material medium than having nothing, because if you have nothing, then you have to come up with some other entirely different explanation for why those two phenomena occur.
Which again, like I just pointed out, it's not complicated at all. I throw momentum into the bucket. The bucket's going to move.
So I believe that that is a reason. So I see Lori, you raised your flag. You have a question or a comment?
Yeah. I just you make some really important points, especially regarding inertia. So I just wanted to throw out.
I won't play too much of this part because these people, like I said, they're just way off in tangents.
Quickly, my idea of what the ether is, which is very similar to yours, because I think we both realize that there is something like an electron-positron pair or something like that. Okay. So,
no, I don't think the two are very similar from my own hearing of it. Franklin's theory seems to me to have a very mechanical, ether is bits, and the bits are like dominoes. They bang in, they compress, and then they decompress, and they compress and they decompress. He doesn't have any vortices as far as I know. He hasn't stated explicitly that he thinks there's some need for a bunch of tornadoes to be spinning all over the place.
So through the work that I've been doing, I've come to the conclusion that, first of all, there's only one ether in my model. Okay, everything is ether. Okay.
Right. So this is where conversation breaks down again too, because clearly I'm saying there's one force, but clearly I'm saying there's 3 different expressions of the force. You can You can put the little bits at a frequency and create something called photons. You can segregate the force for the fact that it's electron force and proton force. It can be red and black, however you want to distinguish it, square and triangle. There's two elements to the fundamental nature of the force. It has two different kinds, square and round. It doesn't matter how you distinguish the two. And they affect electrons and protons inversely. So that's another expression of the force, and that's what we see as magnetism. And magnetism essentially is just electrons being affected, which is just affecting, again, the force between electrons. And again, that's back to photons, and that's electricity. Electricity moves through atoms. Atoms transfer electricity between the pressure of their electrons. Their electrons move, and that electron movement is transferred from one atom to another atom to another atom to another atom. That's electricity. So yeah, one field, one force, but yeah, it has three different expressions, or possibly four if you want to count electricity. But electricity really is just photons trapped between electrons.
Okay, so even matter is ether, okay? So there's three...
So even matter is ether, okay, fine. So you have compression that moves through the ether at the speed of light, compressions. And then you somehow have matter, which is also some sort of compressions, but they don't move the speed of light. So they're somehow moving in circles or doing some other kind of thing to use up all their speed of light powers. I could go for that. The only problem being is that you have to explain the consequences of that, in the sense that there has to be some reason they're in circles, or they're in squares, or they're in back and forth. You have to explain where the paddles are. You have to make them out of something. So you have to accept the existence of things like electrons and protons. Then you have to accept the existence of the thing called charge, which is the fundamental difference between electrons and protons. The fact that they attract each other and they repel their likes.
Kinds of ether, but it's all one ether. So let's say the universe started, I call it primary ether. Primary ether is inertia. It's one and the same.
So it doesn't even mean anything. I mean, primary ether is inertia, so it's standing still. Okay, primary ether is standing still stuff, or whatever, or it's stuff this far apart. It's stuff not compressed. Is compressed. You have to give it some sort of state. The dominoes are all up. The dominoes are all down. Something. You can't just say it's inertia. Inertia is a function. You can't turn inertia into a thing. Okay, it's a function. It's something something does. It's not something something is.
And okay, I just want to point out that I got this idea from studying superfluids and Bose-Einstein condenses.
Yeah, I don't know how you study those because they don't exist. Okay, so you're just like, okay, fine. You studied this bizarre, abstract, theoretical physics models that have, in just a bizarre sense, been turned into any kind of reality. I mean, the experiments are as bad as entanglement experiments in terms of any credibility. Even imagining Bose condensates absolute zero, what atoms do in such circumstances, like we can somehow do that. It's like saying we can make an electron and place it in space and view it as if we're not going to affect it with our viewer. There's no way we can do that. We can't feel it without touching it.
Seas. Okay, because this is what they do. When you cool down a material to almost absolute zero, it becomes pure inertia.
Yeah, whatever. So again, it's frozen stuff. yeah, that's right. It is. It's sort of frozen. That's it. You took all the momentum out of it, which I would argue is just taking the energy out of the pressure. But clearly, you can't do that. We haven't done that, and it's sort of getting to some sort of cold fusion kind of theory, almost in a way. But the very idea that we can create even a container that can do this absolute zero thing is just absolute nonsense. So anyway, we'll jump ahead a little bit. Yeah, I don't know if there's much point, just because it's just going to be the same crap over and over again. So yeah, she talked for a while. Let's see if we can get back to the subject here a little bit. And you know, the rest of it was just not really on the subject, so maybe I'll just go with some of my notes and leave it at that.
And breathe so that we can respond to other people who are raising their flag.
Well, so he basically told people to try to be brief and maybe stay on the subject, please. Possibly, could you possibly do any of that?
In my model, there is some experimental justification for this kind of view, which would be a quantum entanglement. And in quantum entanglement, I propose that there are two quantum units which remain perfectly connected even when they're separate.
All right, so clearly Franklin was on saying, okay, these are a couple of the subjects where you can have a conversation between a contrast between particle theory and ether theory. So even though I would have rather just stayed on the original subject was, do we need these two stupid field perturbations to define what a photon is? It's a quantum moving in a pretty straight line. Do we really have to pervert it into all this other nonsense? Does a simple view of that as being quanta at a distance, is there any evidence that that can't be right? And I'd say there's no evidence that that can't be right. There's no experiment that demonstrates where that theory can't work. I would argue that every experiment sort of illustrates that that theory can work. Anyway, all right, so later on, Franklin did attempt to defend his, you know, there's no point in playing the, like I said, they're just way off the subject. So then, anyway, so Franklin starts this by saying, okay, let's contrast theories of particle theory versus ether, and how can we prove one way or the other which one has a better grounding? So they're not on that subject at all. And then he had the sub-subject of the nature of velocity. Are they anywhere near that subject? Nowhere near it. So the funny thing is, too, is the hairy guy wasn't here, but he would have been having a fit. So maybe was here, not here on purpose, because he hates this conversation for whatever reason. He hates it. But he would hate that Franklin did this. He just hate it. All right, so we'll see what he's saying later on here. He has his polarizer, so he's going to attempt to keep making excuses for this very, I think, underdeveloped theory of how polarizers work. And I might as well just summarize it. I'll play a little bit and then I'll summarize it.
Grid polarizer, and what this literally is literally jail bars, because all they have is just very, very, very small wires running up and down, and that alone is enough to polarize even light waves. So you don't need, I don't know, say the thickness, although light waves compared to, you know, the thinnest bar you could possibly put up would still might look like fairly thick compared to nanometers light waves. So I'm not completely giving up on this, but I just wanted to point out that
all right, so so he's conceding some of the point that yes, I was right about polarizers not being very thick and all that other stuff. But then he reiterates his point in a sense, saying that when light's going into a polarizer, it's coming from all kinds of directions. But that's exactly what it's not doing. So if I hold the polarizer up to the sun, and I polarize the light coming from the sun, I'm getting atmospheric scatter light, but that's irrelevant. It's not the image of the sun. The only light photons that are making the image of the sun are not coming at any angle at all. That's the most culminated light you can get almost. It's traveled millions of miles. It had to be incredibly parallel to actually make it to me, in a sense, a lot of it, because there's a, you know, I mean, obviously the sun is huge, so the real angles could be all kinds of angles. So I'm not arguing that culminated means too much. But clearly by the time it gets here, you know, to my polarizer, it's not like it's coming, there's light coming at strong angles. It's clearly can only be coming at these very narrow angles that are the little round sun. So, you know, the polarizer can't be, the thickness can't be an issue. How thick the polarizer is can't be what's stopping the light from getting through. Because there isn't enough of an angular difference for it to be relevant over distance. You'd have to have a very, 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 very thick polarizer for that to be, for that to work. Because the light is coming, generally speaking, from just one tiny location in space. All right, so that was one of the arguments. So I thought that was kind of an underdone as a defense. All right, so I've done the bullet thing. Let's see if there's anything else. Something of the linear weaker than let's see. It's just funny that I can't read my own writing. Evidence of the lensing. Oh, lensing. So yeah, he did bring up the subject. So he was talking about how photons are bent by gravity, or bent by anything really. So he thinks that evidence is significant or something. So we all have to accept that something's moving photons. Well, first, the obvious argument is, how come it doesn't move them slower or faster? So how come whatever this effect, the ether is, the ether can push a photon offline. Well, why can't an ether slow it down or speed it up? If it can push it this way, why can't it push it this way or this way? So that's the first question I would ask, because that doesn't make much sense to me. That somehow it can move it in one direction, but it can't move it in these other directions. It can only change its momentum sideways. It can't change any part of its momentum forward or back. But the real argument I would make is there's absolutely no real evidence that any of this crap happens, that any photon has ever been bent by gravity. The evidence is garbage. All the solar evidence is just in the Eddington experiment, and the rest of the experiments, they can't, by any fair analysis of the data, separate lensing from scatter. They're getting back so little energy from the experiment, and the images they're getting are so unresolved that all they're saying is that the light comes back bent, not that it's bent in any particular direction or with any tendency. The weird thing too is when Franklin brought up that subject, he implied that just the thickness of ether alone. So let's say they claim that the Michelson-Morley experiment didn't work because the ether is moving with the Earth. The Earth is dragging the ether, and therefore you can't see the difference between the surface movement and the ether movement, because the ether is moving almost as fast as the Earth. And he's claiming that thickness in the ether, because of gravity, the ether is thicker around the Earth too, that the thickness of the ether is what's bending the photon. Well, that's still thick ether wouldn't explain why photons are bent down towards the Earth. So doesn't even work as an explanation. The thickness could explain why a photon slows down, but it's not going to explain why it points in a direction, it moves in a direction. So that doesn't really work for me either. What else? Unless you're going to theorize that the ether is getting consumed by the planet's sucking ether like bent space. It's pulling ether in, constantly. Which again will create the problem where I'm going to ask you, where does all that energy go? A bunch of food goes in, but no food goes out? Yeah, I don't think so. So what else did I want to say about it? So yes, obviously I think the lensing evidence is garbage. The galactic evidence is mathematically insane, doesn't make any sense. The lens is the wrong shape. Lots of arguments. Not good evidence at all. Incredibly weak. I'd say the evidence for lensing is worse than the evidence of the two fields doing this with a photon. I think it's a lot worse. It's just so bad as evidence. So that's a counter argument to that. Again, I'll go back to the freeze frame thing. Maybe we all should be obligated to freeze our vision of the universe and explain how the little things are doing, to explain how there's actually a something in places doing something. You can't just say vortice without some explanation of what is controlling the vortice. I guess with some theories it's never going to work because they just keep creating, like the Hilster theory, where they just create another gravity going twice the speed of light, and then one that's going 4 times the speed of light, I guess, and 5 times the speed of light. They'll just create a new force that's affecting the force, and there's another force that's affecting that force, and another force affecting that force, which I think is just circularly insane. This clearly, I would say, all of that extra speed would leak into our perception. We'd be able to see the stuff moving faster than the speed of light. We'd see the effect of instantaneous if it existed. All right. So yeah, there was just one thing I wrote down because he let the Bob guy or Bill or whatever his name is, Bob or Bill, I don't know, what, the religious guy. And you know, again, he does this stuff. We have experiments that show, and he keeps saying stuff like that. So he does, and then when he's asked to, could you provide me, you know, somebody asked for the link to these experiments that show any of this, and then he just starts talking again. Well, we redid Maxwell's equations, and our redo of Maxwell's equations means that every experiment needs to be reinterpreted to verify what I say, which doesn't make any sense at all. So there's no experiment that demonstrates what he says. You know, it's just more, again, committing the same crimes. So the dissidents just end up committing the same crimes conventional physics does. Tiny amounts of evidence, big drawn-out conclusions. You know, separations from any obligation to reasonably, step by step, explain the phenomena that we actually see, the actual experiments, the good experiments. Explain the hard evidence, and don't rely on the mushy, phantasmagorical experiments. Rely on the solid ones and explain those first and explain them thoroughly. And then maybe we have some hope of having a conversation. But if we're all going to be able to rely on way convoluted 10 million assumption black box experiments to say, there, they've proven gravity waves, they've proven this, they've proven that, then there's no hope for a conversation, in my opinion. All right. The need for an ether. Again, I just keep saying it. If you really cut this down, all you're really talking about is stuff moving. That's all this is. The universe is stuff moving. I mean, I don't care what you say stuff is. Something versus nothing. There's a something, whatever it is. Domino, proton, neutrino, muon, I don't care. There's something, and some things are moving. So some things are getting closer together and some things are getting further apart. So there's movement of some things. And I'm just saying, why create the dominoes when I don't need them? I can just flick the domino and shoot it across the room. I don't need to cascade a bunch of dominoes to get the domino across the room. I just need to flick the domino. Alright, so I think that's all we need to do. I think it covers enough of this. And such. So till the next time, so I will email this link again to, you know, I mean, I don't want to explain the obvious to Franklin, but yes, you can subscribe to my channel and you'll see the videos that come up. And there's one that has a 2 in front of it and one that doesn't. So the one with 2 is part 2. So if you didn't see that. This one will be labeled part 3, I think, just to make it consistent. This technically it's about the same stuff, but it's not. But it's technically the same subject, but of course the same subject is never the same subject because of tangentitis. I'm just trying to think if there's something really important that I'm forgetting to mention. So yeah, I'd rather just have, you know, this me arguing with you in the room talking about it doesn't seem very productive. So I mean, I'd rather you just make videos on your own channel and, you know, you cite some questions that I need to answer and I'll cite some questions you need to answer or whatever, and have a more constructive interaction about what we have doubts about each other's practicality of each other's suggested mechanisms. But yeah, me arguing with this wacky room doesn't make much sense. Anyway, till the next time and such. And so forth and whatnot.